Problem 31, section 7.2. The integral of tangent to the 5x dx. Let's break this up. Tangent cubed x, tangent squared x. Tangent squared x is the same thing as secant squared x minus 1. So let's put that in. And let's multiply the tangent cubed x in. Split up the integral. And let's solve this part first. Tangent cubed x secant squared x. Let's use u sub. U equals tangent x. Du equals secant squared x. So that gives us u cubed du. Oh. And the integral of this is u to the 4 over 4. And if you want to plug that back in terms of u, it's tangent x, so that is also over 4. And that is what we have for this first part, tangent cubed x secant squared x. So that works that way. And now we got to take care of this minus tangent cubed x. Tangent cubed x is also tangent cubed x is the same thing as tangent squared x tangent x. And as we know from our previous example, tangent squared x is the same thing as secant squared x minus 1 tangent x. Let's do the same thing we did earlier in another problem by factoring this in. Gives us the integral secant squared x tan x minus tangent x. Now it'd be helpful if we could break this integral up again by just doing this part, secant squared x tangent x. We'll use the same u sub, u equals tangent x, du equals secant squared x. That gives us the integral of u squared du, which we can do is u cubed. Oh wait, no, it's just u, excuse me. So the integral of u du is u squared over 2. Let's put it in terms of tangent. So tangent squared x over 2. And now we still have to take care of this tangent x. And it's pretty self-explanatory. Tangent x is equal to ln secant x. So let's put this all together. We have tangent to the 4x over 4. And we got this whole part we have to multiply or subtract out. So we have tangent squared x over 2. And we also have ln secant x. And that is our answer. I mean, you can always further simplify this. Tangent to the 4x over 4 minus tangent squared x over 2 plus ln secant x. And this is our answer.